Guys, welcome again today. Today we're going to discuss how to choose the component for our power supply, how to calculate the values, calculations, what are the factors to consider when choosing the component, okay? So this is what I'm going to do. So we're going to dwell much on calculations. How do you calculate the value? Let's bring our circuit. So this one, how do you get the value of this capacitor? What are the voltage? How is the voltage going to vary from these stages? So we're going to calculate into details. So make sure you watch the full video so that you don't miss any part of the video, so that you get clear information on how to calculate and choose this. Let me have this transformer here. How do you choose this transformer? Step number one, for us to be for you to choose a transformer for this power supply, one, you need to know your input, the input voltage, Vin, the input voltage. We normally know that the input voltage is AC voltage, alternating current. Okay, this input should match with your main supply voltage. What do I mean here? What I mean here is that each country, we have some difference of voltages. For us here in Kenya, a single phase voltage is 240 volt. Let me say like that, 240, 250. The frequency of this voltage is 50 hertz, which is not the case like in US, in some other country. So you will have to check your input supply voltage. Another country you can maybe find is 110 volt, 60 hertz. So you will have to determine your input. That is number one. And you should know the frequency of that voltage. Number two, when choosing a transformer, you need to know the output voltage, V out. What output are you going to get after this at the output of this transformer? Okay, what is your voltage output? Like the transformer I have here gives us 12 volt AC. The transformer gives 12 volt or still give you alternating current. Okay, so for you to be able to choose a transformer, the output voltage of a transformer should be higher than the desired output voltage. Let's say in our case, we want to design a 5 voltage power supply. So meaning that the voltage from the transformer should be higher than 5 volt. This is because to avoid voltage drops. So because there will be voltage drops, some components will overheat. So we are going to discuss those in details. After knowing the output voltage, number three, you need to know the current. What is the current of that transformer? Like in this case, you can see here. The input voltage is 220, 50 hertz, 12 volt, 1 amp. Okay, like in case of this transformer. So the current for this transformer here is 1 amperes. Is what you will get at the output of that transformer. Then you will have to consider your load current. Suppose your output current, you want to design a 5 volt, 1 amp, like you are going to design to design. So the transformer should be at least 12 volt, 2 amps. Okay, something like that, so that you will be able to achieve. It will be able to provide to you your 1 amp at the output, to avoid components to overheat. Because if the load is draining more current, the components will start overheating and the risk of burning. So always consider that the current should be slightly higher than the output current, the current which the load is going to drain. Then you have to consider the power rating of the transformer. This can be calculated as just a simple one. We are not going to do into details here. Here in transformer, we are not going to calculate anything because the manufacturer has already made things easier for us, as you can see. Then you'll have to 5 is the type of transformer. Which type of transformer are you going to choose? So in this case of taking many AC to a low voltage is a step-down transformer. You need to take a step-down transformer which will take 240 volt to 12 volt. So if it is the opposite, like you want to get to get 12 to 40, there now you will need a step-up transformer. step up. So in case of power supplies, we need a step down transformer. So those are the factors to consider when choosing a transformer when designing a power supply. Then second part, how do you design or how do you choose this bridge rectifier? Okay, a bridge rectifier is made up of semiconductor diodes, as we have explained. Okay, a bridge rectifier is chosen because it's more efficient. Okay, because it rectifies both halves, like we have explained here. If it's positive, this one changes to negative, and vice versa. You still maintain, you still rectify both the changes. The bridge rectifier is made up of 4 diodes, as we have explained, where 2 diodes conduct at a time. You see, 2 diodes, this one and this one at a time, and that one at a time. Now, after rectification, what are you going to, what will happen after rectification? After rectification, we'll have to calculate the average voltage. Average voltage. So the voltage average after rectification is calculated as 2 pi times square root of 2 times the voltage. The voltage you are getting here, the input voltage, the VRMS from the transformer, what you are rectifying. So in our case, we have a transformer which is giving us 12 volt AC. Then, so we need to calculate a VRMS voltage, average voltage for this case. So it will be 2 pi, okay, times 12 volt, which is around 10.803 voltage. Okay, so this is the average voltage you're going to get after rectification. Okay, the average voltage, like the least voltage you will get if any like the least voltage you will get is that one. Now let's calculate the peak voltage. So the maximum voltage you will get now. This is now the most important voltage. So the peak voltage you are going to get after rectification will be square root times the VRMS. So root 2 times the VRMS. So meaning that you are going to get this times 12. So which is 16.97 volts. So this is what we are going to get after rectification. Now this, we use silicon diode. For a silicon diode, in a full wave rectifier, voltage drop across the diode is 0.7 voltage. So 0.7 voltage. So since two diodes are conducting at a time, meaning that we have a double of this voltage drop at a time. So meaning that if we want to calculate the voltage drop, it is 0.7 times 2, which is 1.4 volts. So this is the voltage drop when the rectification is taking place. Okay, guys. Then let's now calculate. Let's see the peak voltage when we consider the voltage drop after rectification. So this will be equal to, now this one is 16.97 minus 1.4, so 5.57 volts. So this is now the voltage, the actual voltage you will get at the output after rectification by considering the voltage drop. Now another factor is that when after rectification, the frequency will double. What do I mean? If my frequency output will be equal to frequency input times 2. So if my frequency input is 50 Hz, meaning after rectification is going to be 100 Hz. So this is what is going to be at the output after a rectification. So those are the simple calculations we do after a rectification. Now, after rectification, the rectified DC still have AC component. So we need to remove this AC component by smoothing, by filtering. For us to be able to do that, we have to choose first. Let's say choose a capacitor which will be able to smoothen, to filter the DC, to remove AC component from the rectified DC. Because this rectified voltage, we still have voltage ripples, meaning voltage is not that smooth, still contain AC and DC. So meaning that we need to allow to remove this variation, voltage ripple. We have to remove these ripples from the voltage. So we'll have to put a percentage of which we are going to allow that the voltage variation, the amount of AC in DC component is of this level. So in my case, I chose 100 millivolt. Okay. So for 100 millivolt, this one, this is like 0.1 volt. Okay. Because I don't need ripples in my voltage, output voltage. So I need to get a constant DC at the output. So that's why I give it a voltage ripple value of 0.1. You can also give it to yours. Then I need to calculate the value of that capacitor. So for me to be able to calculate that, I will calculate is that the current output, the output current, 2 pi times the frequency times the voltage output. Now let's see here. That power supply I'm going to design, it is a 12 volt. It is a 5 volt, 1 amp power supply. Okay. Then from here, the 1 amp is the current output. The 5 volt, it is the voltage output. I out is 1 amp. V out is 5 volt. Then we have the frequency. We have said that the frequency as double, so is 100 Hz from our explanation as we have discussed. Okay. Then now let's see. Let's replace things here. So we have 1 amp, 2 pi times 100 times 5 volt. So this will give us approximately 318.399 something like that microfarad. I've calculated the microfarad already. So this will give us something like this. Okay. Then for me to be now in the market, if you don't find the exact value, go for the capacitor which has higher value, not lower. Like in this case, let's choose 470 microfarad. So this one will be able to remove ripples from this rectified DC. So that is how simple it is to calculate the capacitor filter for this type of project we are doing. So now let's go to voltage regulator. Now that this rectified DC, now we have it smoother, something like this. So it's not constant, it's still varying. You can see, you measure at a time, maybe it's 3, another time it changes to 4, another time it changes to 5. Now our aim is to get 5 volt constant DC output. So that means we have to come up with another component which will perform this task for us. So that is a voltage regulator. Voltage regulator is the one going to provide for us the required output. So how do you choose a voltage regulator? Because you don't calculate a voltage regulator, you choose. We have 2 types of voltage regulator. We have linear voltage regulator and we have switching voltage regulator. So in our case, we are doing linear voltage regulator. So for linear voltage regulator, we have 2 types. Linear, we have 2 types. We have the one which provides positive voltage at the output and the one which provides negative voltage at the output. So the one which provides 8 voltage at a positive voltage at the output has a prefix. The prefix is normally written 78, and for negative is written 79. Now for the level of voltage, so let's say it is the power supply is going to give us 5 voltage at this case, in this case, so it will be 7805. If it's 909, if it's 12, 7812, 7809, 7815, 7824, something like that. So this 78 will give you a positive voltage, the normal one. Then if it's a negative, like for amplifiers, you need to feed in a negative voltage. You will need 79. So it is 7905, 7909, 79, 12, 79, 15. So this one will give you a negative voltage. What do I mean by negative voltage and positive voltage? At the positive, so this voltage is just measured, like for this one, you will get 5 in a meter. Just measured for 5. But in this case, you will see a negative. It will be negative 5. It will show you that this voltage is a negative voltage. Now, how do you choose a voltage regulator? Number one, know the nature of the output voltage. Like in this case, we are going to use we're going to get to achieve a positive output voltage. So you need to choose a positive voltage regulator, which is a linear voltage regulator, which is a prefix of 7805. That is what we're going to use. If it's a negative, then it is 79 there. So the first two is the nature, voltage nature, and the second two, the following 2 digit is the voltage level. So that's how it is. So you need to know the nature of the voltage. Then you need to know the input. What is the input voltage? So the input voltage for regulation to happen, the input voltage must be higher than the output voltage. So meaning that if you want to achieve 5 volt, the voltage which should be fed to voltage regulator here should be more than 5 volt. Okay? Then you'll have to consider your output. In this case, like we need 5 volt at the output, so we'll go for 7805 IC. In the integrated circuit, I'm showing it here. It is there. It has 3 pins. I'm going to show you how to connect it. Then so a positive voltage. If it's 9, you go for 7809, 12, 7812, 15, 7815, and so on. You'll have to consider the output current. Okay? Output current, the current output. So you'll have to check the data sheet of that linear voltage regulator. One of the most important factor in voltage regulator is power dissipation. This how does it take 12 volt to 5 volt? By dissipating power in the form of heat. Remember, these components will overheat because it will dissipate power in the form of heat to give you your output. This will overheat, so you will have to come up with a provision how to deal with that heat. The cooling system. So normally a heat sink is used. So this one is a heat sink. So this one will absorb the heat from the regulate, the IC. You can also include a fan, so something like that. So you'll have to consider the power dissipation. So always consider the cooling system. How do you deal with it? Then the efficiency. The efficiency also is important. When you want to achieve to design a power supply, you have to check the efficiency. What efficiency do you want at the output? It is very important too. Okay. Now, so let me say so. The efficiency for this is 60%. But if you want to achieve like 90, 95%, this is not going to give you such efficiency. The last one is the protection feature. You have to protect this voltage regulator from overcurrent, heat shutdown, what you have explained, short circuit, and the reverse polarity. So it's just something like that. So that is how you calculate, and that's how you design a 5 volt power supply. I've put a link in the description for the video which shows you how to design now each component. So you go to the description, you go and find the video, a full video whereby I've designed and I've tested. Thank you.